The next example that we're going to look at is an example of the use of the chain rule. Here we have the function f of x equal to 2x cubed plus 7 all to the power of 4. And we're going to have a go at differentiating this function. And as I said before, we're going to use the chain rule. Now, the way that you know that you have to use a chain rule is when you have one function, in this case, this function 2x cubed plus 7, inside another function, which in this case is something to the power of 4. So if you can replace the middle part with just a pronumeral, say u, and you get something that's nice to differentiate, so in this case if we rewrite this function as u to the power of 4, we can see that if I was asking to differentiate with respect to u, this would be an easy problem. Bring the 4 down, reduce it by 1. But it's complicated by the fact that instead of just a u in there, we've got a 2x cubed plus 7. So each part of this, the 2x cubed plus 7 and the power of 4, is easy to differentiate on its own, but when they're sort of nested inside each other like this, it becomes a chain rule problem and it becomes a little bit more involved. If you remember, the chain rule said this: dy dx is equal to dy du times du dx. And we sort of noticed last year that you can kind of imagine that the two du's would cancel and you'd get your dy dx happening, which is why this, I guess, is true. But we're going to talk about how to apply this to the problem. We've already identified what our u is. Our inside function u is equal to 2x cubed plus 7. So I'm going to write that down here. U equals 2x cubed plus 7. And that means that my function, my f of x, in this case I'm just going to call it y, is equal to u to the power of 4. Now, each of these separate functions we said were easy enough to differentiate on their own. I can differentiate this one. Dy du is equal to 4 times u cubed. And this function here, u, I'm going to differentiate du with respect to x, so du dx. It's going to be, bring the power down here, so 3 times my 2 is 6x squared. And we know that the constant just goes to 0, so this is my derivative. Now, let's have a look at what the chain rule says here. It tells us that dy dx is equal to dy du times du dx. And we've just calculated dy du and du dx. So if I want to find out what my derivative is, dy dx, I can get that by going my dy du, this one here, 4u cubed, multiplied by my du dx, which is here. Now, we didn't have any u's in the original question, so we're going to need to replace that u with 4 times 2x cubed plus 7 cubed, multiplied by 6x squared. So my function, when I differentiate it, f prime of x, is going to be 4 times 2x cubed plus 7 to the power of 3 multiplied by 6x squared. And we're going to have to tidy that up. 4 times 6 is 24. The x squared is going to end up out the front because we like to write it there. And I get 2x cubed plus 7 all to the power of 3.